With its hot summers and extremely cold winters, Canada consumes almost 600,000 gigawatt hours of electricity a year. And 15% of all that energy comes from nuclear power. So, how do they do it? Located in Ontario, Canada, this is one of the world's largest nuclear power plants. Covering more than 3 square miles, Bruce Power has 8 nuclear reactors, each capable of generating more than 750 megawatt hours of electricity. Altogether, that's enough to power a city of 5 million. And for the 4,000 people who work at Bruce Power, cleanliness is an obsession. When leaving a radiation area, each employee must pass through a full-body radiation monitoring gate. This sensor makes sure that employees haven't been exposed to radioactive particles. Today is a special day because the engineers at Bruce Power are refurbishing 2 of their nuclear reactors. And that means for the first time in nearly 30 years, they'll open their reactor and allow a team of engineers to work on the core. Giving a nuclear reactor a makeover is a multi-billion-dollar job. Bruce Power CEO Duncan Hawthorne explains.
The key challenge, I think, is being able to disassemble a reactor core that's been in operation for 25 years. That involves disassembly of a lot of irradiated components. Clearly not a task that we could send men in to do. It required the development of first-of-a-kind robotics.
So a team of custom-built radiation-proof robots are brought in and controlled remotely from the power station's retube control center. With the radioactive tubes removed from the core, it's safe for the team to go in. The reactor core is a big round disc with slots that hold hundreds of radioactive tubes. To avoid contamination, anyone who goes near it must wear these protective suits. Once the reactor core has been checked, cleaned, and rebuilt, it'll be time to fill it up again with uranium. Uranium is found in dark rocks known as pitchblende. But these rocks are less than 1/4% uranium, so they'll have to mine over 400 pounds of ore to produce 1 pound of natural uranium. The uranium is then packed inside 1.5-foot long rods, made out of a heat and corrosion-resistant metal called zirconium alloy, and the rods are welded together into power-packed bundles. Each of these uranium fuel bundles can produce enough heat to generate 1 million kilowatt hours of electricity. The 480 tubes in the core can each contain a dozen fuel bundles. And when all 5,760 bundles are in place, the reactor is started up. The uranium atoms inside the fuel rods are very unstable, so when they are bundled together and surrounded with heavy water, the neutrons start to speed up. These tiny neutrons can pass through the zirconium walls of the fuel bundles, flying from one tube to another, until they hit another uranium atom. And when they do, the atom splits, releasing energy and even more neutrons, and you have a colossal nuclear chain reaction. Of course, the problem with nuclear chain reactions is you have to be able to stop them. Otherwise, you get what scientists call a nuclear meltdown. However, the guys in the control room are relaxed. Not only is the reactor sealed within 6.5-foot thick reinforced concrete walls, it also shuts down automatically if the temperature rises or the pressure drops too quickly. This keeps the chain reactions in check and prevents a catastrophic explosion. But there's still plenty of power to generate an immense amount of heat. The heat is used to turn water into steam, a process they monitor carefully from the control center. These massive turbines laid out in the 1/4-mile long, 20-story tall turbine hall turn the steam into electricity. Like a violent steam storm spinning a supersonic windmill, the turbine revolves at 1,800 RPM, driving a generator. This giant turbine converts the movement into more than 750 megawatts of electricity, enough to meet the needs of 500,000 people. Which leaves one small problem: radioactive nuclear waste. After a year or so in the core, the fuel bundles are depleted, but they are now extremely hot and radioactive. They're so hot, the rods have to be stored in water for 10 years before they can be safely disposed of, as Environment Manager Doug Borum explains.
We put them in these pools to actually allow them to cool down in temperature and also allow the radioactivity to dissipate.
This 26-foot deep reservoir has over 730,000 radioactive fuel bundles sunk in its depths.